Hi, I'm Jessica Van Brummelen, and Phoebe Lynn and I will be talking about how we engage teachers to co-design integrated AI curriculum for K-12 classrooms. With AI systems becoming widespread in our homes, phones, and even cars, it's becoming critical for everyone, including children, to be able to recognize AI, understand how it works, and evaluate the impact of AI technology on society. However, introducing AI curriculum in K-12 classrooms can be challenging. For example, since AI can intersect with every subject in school, like AI-generated art or the math behind neural networks, teachers of all subjects should feel empowered to teach AI, yet teachers often feel they lack sufficient understanding to teach AI and the capacity to include more curriculum on top of their existing curriculum. To address these challenges, we employ a value-sensitive design approach to create teacher-centered design recommendations for AI curriculum and tools. We'll show that this approach provided rich data to answer our two research questions, including how might we address K-12 teachers' values and considerations when designing AI curriculum and tools, and how might AI tools and curriculum be integrated into core subject curriculum. And we did this through co-design workshops with K-12 teachers, which we broke into 2 sessions over 2 days. On the first day, we presented and had discussions with the teachers about what AI is and why it's important. We also shared various AI teaching tools, including ML for Kids, AI for Oceans, and Google's Teachable Machine. Afterwards, teachers individually investigated the AI tools and brought ideas for how to integrate the tools into their own subject material. On the second day, we broke into groups, with each group having at least one AI researcher and 4 to 5 K-12 teachers, and designed curricula with respect to teachers' core subjects and AI tools teachers thought would be useful. For a portion of this co-design, we specifically focused on integrating AI ethics into curricula. Finally, we concluded with the second discussion about AI and why it's important to teach, to see how teachers' views may have changed. The workshops resulted in 4 curricula, the first one on the left being physics curriculum, where ML for Kids is used to predict paper airplanes' flight distance, the one in the middle being social studies curriculum, in which students investigate the Crown Act, a law prohibiting race-based hair discrimination, train teachable machine models to recognize professional versus unprofessional hairstyles, and discuss whether this is a good idea or not. The one on the bottom right being ESL curriculum, in which students develop machine learning models in ML for Kids to recognize the pronunciation of English words, and the one in the top right being literacy curriculum, in which students create image recognition models for vocabulary words.
To address our first research question, we conducted an in-depth analysis of the workshop recordings and transcripts, focusing on the value and considerations of K-12 teachers when designing AI curriculum and tools. From our workshop with 15 teachers, we found 4 common values and considerations across subjects: evaluation, logistics, collaboration, and engagement. If you'd like to understand these in more depth, you can check out our paper. To address our second research question, we continued our analysis of the transcripts combined with the co-created curriculum, focusing on where and how teachers made connections between AI learning and the core curriculum. First, it was easy for teachers to come up with activities that involved generating and reflecting on data. In the literacy curriculum, teachers wanted students to train a classification model on Teachable Machine. Teachable Machine, as well as ML for Kids, were 2 of the most popular tools due to their transparent data training capabilities. Second, the active reflection aligns well with many subject standards and AI literacy competencies. In the integrated AI physics curriculum, students were still able to plan and carry out tests like they would have in the original curriculum by testing models they built in ML for Kids and reflecting on what worked and what did not work. Third, teachers were excited yet apprehensive to connect AI ethics into their curriculum. All of our co-designed curriculum had an ethics component. For example, the social studies curriculum that anchored on the real-life policy called the Crown Act asked students to discuss how different people groups could be affected if we designed AI algorithms to classify outfits and hairstyles as unprofessional or professional. For teachers who want to facilitate these discussions but aren't sure how, AI educational tools can build in ethical dialogue and scaffolding so that ethics is less intimidating for teachers. We also saw 3 main ways teachers were successful in making AI connections. First, teachers saw similarities between AI and human behaviors, such as how the iterative cycle in ML is similar to the way we iteratively form opinions and update our mental models. Second, teachers saw similarities between subject standards and the Big 5 AI concepts. And lastly, teachers discovered connections by thinking about how their curriculum could extend into AI. For example, if I'm teaching Shakespeare in my English class, is there a way I can also talk about natural language processing? You can find further details in our paper. In conclusion, we shared 4 values and considerations that teachers have when designing integrated AI curriculum and 3 entry points for connecting AI competencies with core standards. We published all the curriculum that came out of this workshop and discussed how tools can make this kind of integrated learning possible and easier for teachers to adopt. More importantly, we want to stress the importance of bringing teachers into the design process so that we can work towards building AI educational tools that can be used widely in existing classrooms. Thank you, and feel free to reach out for questions.